Okay, whoops. This is all about thermodynamics. So the first law of thermodynamics says energy is not, probably can already finish it before I keep going, created nor is not created or destroyed. It is only transformed. So when you do a chemical reaction, you're not creating any energy, you're not destroying any energy, you're only transforming it. So you might be taking like the sun's energy and turning it into glucose, which is chemical energy. That's what we do in photosynthesis. Well, we don't, but plants do in photosynthesis. The second law is that all systems tend towards disorder. And what that means is we're always doing chemical reactions. It's how we stay alive. And every time you do a chemical reaction, some of the energy that was in that chemical reaction to start with is lost to the surroundings or to the universe as heat, generally heat. It could also be light. There's other ways it can be lost, but it kind of escapes from the system, from the reaction, and a lot of times that is lost as heat. Well, heat is the measurement of kinetic energy of molecules, and that kinetic energy is random movement. Well, anytime you have random movement, that's disorder, that is chaos. And so when you lose that energy during that chemical reaction as heat, or as light, it's going to be more random than it was in a bond or in, however it entered that chemical reaction. And so it's going to become a more disordered form of energy, and we call that disorder entropy. And so another way of saying this is that the universe is always increasing in entropy, increasing in disorder. And that's all because of this inefficiency. We're not 100% efficient because we're always losing a little bit of energy in the form of heat. So I can state the first law of thermodynamics. I can state the second law of thermodynamics. I can define entropy, which is just disorder. And the last I can statement is I can explain how energy is lost during a reaction to increase disorder. And that goes back to, as a chemical reaction is happening, some of that energy escapes. It's not all transferred to the products of the reaction. And when it escapes, it tends to escape in a very random or disordered type of energy, such as heat. And so that is a quick review of thermodynamics. We don't go really deep into that with biology, but it does give you an idea of how that is happening and how it relates to living creatures, because that, as biologists, is what we care about. I hope that helps. If you have any questions, let me know.